Okay, so in this video, we are going to continue with some real-life problems. Okay, example 1. A boy is pulling a sack of soil with a force of 125 Newton at an angle 40 degree with the floor. So the first question is, draw a horizontal and vertical components of the force. So the question gives you the force pulled by the boy is 125 Newton. And you must resolve this force into two components. Okay, let me draw it over here. 125 Newton. Okay, so I'm going to resolve it to Fy, vertical component, and Fx, horizontal component. Okay, next. Find the horizontal component of the force. To calculate the horizontal component or vertical component, it is easier if you form a triangle. So based on the resolution of force diagram that you have drawn just now, I am going to form a triangle by moving one of the vector force. I think I want to move Fy so that I can form a right angle triangle. So this is your right angle triangle. And don't forget the degree of force from the ground, which is 40 degree. Okay, so horizontal component. Okay, so as I have mentioned in the previous video, if you do not know whether to use sin theta or cos theta, you can use both. Just derive both and decide later which one to use to find horizontal or vertical. But in this situation, I already know that if I want to find horizontal component, I need to use cos, because the formula is cos theta is adjacent over hypotenuse. So from my triangle, the component adjacent to theta is fx. So I'm going to straight away put fx in the formula over f. So to find fx, it is f cos 40. You substitute the value of f, which is 125 Newton, cos 40, and calculate it using a calculator. You will get fx is 95.76 Newton. Next, find the vertical component of the force. So now I think you should know by now that if for horizontal component based on the triangle, okay, you use cos 40. So for vertical component here, you are going to use sin 40. Okay, please bear in mind, not every triangle you can use sin 40 to find the vertical component. So you have to analyze the position of angle. Okay, so do not memorize, instead understand the triangle. So in this situation, if I want to find the vertical component is opposite to the triangle. Okay, so it's opposite to the triangle. So that's why I'm going to choose sin 40. Okay, sin 40, Fy over F. So Fy is F sin 40. Substitute 125 in the formula and you will get 80.35 Newton. So that is your vertical component. Okay, let me highlight horizontal component as well. Okay, so if you want to recheck, whether your answer is correct or not, you can use Pythagoras Theorem. So from your answer just now, Fx is 95.76 Newton Fy is 80.35 Newton. And if you form a triangle here, you can use Pythagoras Theorem, which is C equals to square root of A square plus B square. Okay, so here I'm going to put 80.35 square plus 95.76 square. Just use your calculator and you will get the answer approximately 125 Newton. So if you get the answer same as the value given in the question, 125 here, it means that your horizontal component and your vertical component is correct. Okay, next. Example 2. A man is pushing a lawnmower with a force of 85 Newton at an angle 45 degree with the ground. So calculate the horizontal component of the force that causes the lawnmower to move forward. First, we have to draw the force acting downward and split or resolve the component Fy and Fx. So the component that causes the lawnmower to move forward is actually Fx. So the question wants you to find Fx. Okay, so here, calculate the horizontal component. I am going to move the vector force Fx here to down there so that I can form a right angle triangle. So that is your Fx. Don't forget your theta, 45 degree from the ground. Okay, so horizontal component, I think by now you already know that to find the horizontal component and the angle given is from force to the ground, Fx. So you should use cos 45, which is Fx over F, and you will get Fx equals to F cos 45. Substitute F, 85 cos 45, and you will get Fx equals to 60.1 Newton. Next, calculate the vertical component of the force that presses on the lawn. Okay, so you know by now, the force that causes the lawnmower to move forward is Fx, whereas the force that presses on the lawn is Fy. Okay, so use sin 45 because sin is opposite over hypotenuse. Opposite of 45 degree is Fy over hypotenuse F. So Fy is F sin 45. Substitute the value of 5. You will get 60.1 Newton. Okay. Next, if his mass is 65 kilogram, calculate the total downward force acting on the ground. Okay, so here you already know the man is pressing down with a force of 60.1 Newton, and the man himself has mass of 65 kilogram. So we need to calculate the weight acting downward by the man to get the total downward force. So total downward force is Fy plus weight of the man. Okay, so Fy here is 60.1. Okay, so for calculation, I prefer to use negative 60.1. The reason is because the force is acting downward and the weight of the man is actually mg. Okay, so recall that weight is mass times gravity. So his mass is 65 and gravitational acceleration is 9.81, and you will get 637.65 Newton. Okay, so I'm going to substitute in the formula here. Similarly, I am going to put negative in front because weight acting downward is in negative direction. So 637.65, and you will get negative 697.75 Newton. Okay, or you can write it like this: 697.75 Newton downward without writing the negative sign. Okay, next. If the man pulls the lawnmower instead with the same force, what happens to the total downward force? Okay, so just now the situation given is force is acting is pushing downward. The man is pushing the lawnmower downward. But here in this situation, in the new situation, the man is pulling the lawnmower with the same force and with the same angle. So if you resolve the force, you will get the same answer, which is Fx is still going to be 60.1 Newton and your Fy is still going to be 60.1 Newton. Okay, so here weight acting by the man is still acting downward. Okay, so weight is still acting downward, so your total downward force is still Fy plus weight. But take note of the direction of Fy here. Okay, since the man is pulling the lawnmower, so the vertical component is, the direction is upward. Okay, so in calculation, since the direction is a positive direction, you are going to use 60.1 Newton because the direction is upward. Okay, so we take direction upward as positive, direction downward as negative. Plus weight of the man as calculated earlier is negative 637.65. You will get 577.4 Newton, which is lower compared to the previous question. Okay, downward, to put here downward. Okay, so this means that a greater force is exerted if the man pushes the lawnmower. Okay, so pushing the lawnmower is a more efficient way compared to pulling the lawnmower because it exerts more force downward. Okay, so we have another 2 questions that we will continue in the next video. Thank you.